this is going to be a quick video with just a little more notation about continuity. We said that fx is continuous at x equals c means that the limit of fx as x goes to c exists and it equals f of c. Similarly, we can define one-sided continuity using one-sided limit. A function is right continuous at a point if the limit as x goes to c from the right equals the function value. Same goes for left continuity and left limits. So if we look at this piecewise function, as we approach 0 from the right, we see a hole in the graph. The limit from the right does not equal f of 0, but the limit from the left does. The limit from the left is 1, and f of 0 is also 1. If we just change the function value at 0, then the function switches from being left continuous to right continuous. Now for g, as we approach from the right, the limit is 0 and the function value is 0. As we approach from the left limit is 1, and that's not equal to the function value. It's very common to see one-sided continuity when you transition between different formulas in a piecewise function. The other new notation is for continuity on a whole interval, not just at a point. When we say f is continuous on an open interval from a to b, we just mean that it's continuous at every point in the open interval. For an interval that's closed or closed on one side, it's a little more complicated. So when we have the interval which includes a but not b, we also want the function to be right continuous at a. It's continuous for all those values a little bit above a, and as you approach a from above, you're also getting to fa. Something similar happens when we include b. We want the function to be left continuous at b, because it's continuous for all those values that are a little smaller than b, and as we approach b then from those smaller values from the left, we also want to approach fb. And then the interval including both a and b is exactly what you would expect. It should be right continuous at a and left continuous at b. Consider the function shown in this graph. Pause the video and decide what are the maximal intervals where this function is continuous. We should start by identifying the points of discontinuity. There are two jump discontinuities at x is -3 and x is 1. And there's also an infinite discontinuity and vertical asymptote at x equals 4. So we know that intervals of continuity are going to go between these discontinuities, and we just have to be careful about the endpoints. You should get these intervals. The function's continuous from -infinity up to and including -3, because the function is left continuous at -3. Then we have the open interval from -3 to 1, the closed interval from 1 to 4, because we have right continuity at 1 and left continuity at 4, and then finally the open interval from 4 to infinity. Notice that we never include infinity or -infinity. A function can't be continuous at infinity because there's no such thing as f of infinity. That doesn't make any sense. Please go on to the next video, where we'll see how the notion of continuity is useful for calculating limits.